Hi, this is Dave Littman with Truth in IT, and we are doing a preview of the RSA conference in 2017, and today I am speaking with Dr. Eli David, CTO of Deep Instinct. Eli, welcome.
Thank you very much.
Okay, so today we are going to talk about artificial intelligence and deep learning algorithms as it pertains to cybersecurity and advanced threat protection. So tell us a little bit about, I guess, where you see the difference being between deep learning and machine learning and how that lays the underlying foundation for your guys' technology.
Basically, deep learning is the closest we've got in computer science to creating something that mimics our brain, or more accurately takes direct inspiration from our brain. In our brain, our neocortex, we have tens of billions of general-purpose domain-agnostic neurons that can learn from any kind of data without being explicitly programmed to do that. And this is what we're trying to do in the field of deep neural networks, also known as deep learning. Many layers of neurons, hundreds of millions of synapses, and are trying to learn by observing lots of data. Deep learning, as you mentioned, is actually a subfield of machine learning. But there's a big conceptual difference between how deep learning is applied to various problems and how machine learning is applied. Wherever we would like to apply machine learning, we cannot directly feed our data into a machine learning module. We first have to do feature extraction, basically explicitly deciding what are the important properties of the problem. For example, if we're trying to do face recognition, we have to bring image processing experts to tell us that the most important properties are distance between pupils, distance between nose and a mouth, proportions of the face, and only then feed those values into machine learning module. Similarly, if you'd like to apply machine learning to cybersecurity, as there are some good companies who do that, you cannot just take the raw data and feed it into that. You have to bring cyber experts that tell you that the important properties are the API calls that the file makes, the registry keys, I/O interactions, etc. Now, this is very limiting, of course. We're limiting the scope of the intelligence system to those few hundred properties that we decide in advance. Deep learning is the first family of methods within machine learning that completely skips feature extraction. Back to our face analogy, if you'd like to apply deep learning to face recognition, you just feed the pixels directly into the input layer of the deep neural network. No pre-processing, no image processing whatsoever. And similarly, wherever deep learning is applied to speech recognition, text understanding, it's always applied to the raw data, no pre-processing. And this is also the case in what we are doing. We're not doing any pre-processing. We're not telling our system where to look. And we're just feeding our raw data, raw byte values of any file format into the deep learning module.
Okay, and so you've described, Eli, what I like to term the drill bit versus the hole. You know, guy goes into a hardware store to buy a drill bit, and the guy who owns the hardware store says, hey, you don't want a drill bit, you want a hole. Right? So ultimately, the solution that you guys are delivering has to do with advanced threat protection and zero-day malware threats. So talk to us a little bit about how your technology makes you guys uniquely capable to manage those sorts of threats.
Sure. Deep learning has been very successfully applied to various problems in computer vision, speech recognition, text understanding. In each one of those domains, we have witnessed 20 to 30 percentage point improvements in the past 2 to 3 years. This is the highest jump in performance in the history of AI. I've spent most of my life as an academic researcher in the field of AI. We were used to seeing 0.5%, 1% improvement. Suddenly, we see that big jump. In Deep Instinct, when we founded the company in 2014, we were the first to bring deep learning to cybersecurity. And by the way, now, 2.5 years after that, we're still the only company applying deep learning to cybersecurity due to the very high barrier of entry for deep learning. So what we did is we spent most of our first year in the company just developing our own deep learning infrastructure from scratch. And when we developed it, then we moved to tackling specific problems in cybersecurity. The problem we are focusing on is detecting new malwares, new files. There are more than 1 million new malware created every single day. And of course, the vast majority of them are extremely small mutations over previously existing ones. But even the supposedly brand new malware, nation-state APTs, they're far from being brand new. On average, a nation-state APT is 70 to 90% similar in code and concept to previously existing malware. So we're basically living in a world of micro-mutations, some mega-mutations, and evolution, basically. But currently existing solutions have great difficulty detecting many of these new mutations. And that's where we're relying solely on deep learning to tackle this specific problem. We're not using any signatures, any heuristics. We do not do any dynamic analysis or sandboxing, or basically anything commonly used by other solutions. As far as we are concerned, a computer file is just like an image, with the only difference that instead of a bunch of pixels, it contains a bunch of bytes. As such, we're completely agnostic about file format, about the operating systems, executable, DLL, PDF, PowerPoint, Android APK, they're all the same as far as we're concerned. And the way we use deep learning is that we train the brain in our laboratory. We run our deep learning infrastructure on our clusters of GPU machines. We feed in our whole data set is close to 1 billion samples of both malicious and legitimate files. And we feed them again and again to the brain as it tries to gradually improve its synaptic values and better distinguish between malicious and legitimate files. This whole process takes about 24 hours in a laboratory. Basically, the nickname for our laboratory is the kitchen, because that's where we cook the brain. And the result of this cooking is a single brain file. It's about 20 megabytes in size, extremely small, which contains all the knowledge and everything that we trained. And that's the brain we put on the product side and the customer side. Any endpoint, any mobile device, we put it locally on the device, and for each new file that's observed, we pass it through the brain in a few milliseconds, next to zero memory and the CPU footprint, and provide real-time detection and prevention.
Cool. And I love the name of the brain that you cook in the kitchen. So I have to ask you, is like the suffix for the file, the type is like .br or something, or .brn or something like that?
It is funny, but indeed it is. In our internal system, the extension is .brain.
Oh, funny. Oh, that's funny. Okay, cool. So, we were talking a little bit earlier, Eli, and you were using a very interesting analogy between how computer vision would distinguish an image versus how you guys would. And so if you could take us a little bit through that. If you've got, for example, I guess two superimposed images, one on top of another, computer vision would not be able to detect what those images are. But with the underlying technology and knowing sort of almost the elemental building blocks of that image, you could understand what they are. So take us through a little bit of that description.
We're actually constantly curious and looking into to understand why this thing works as good as it does work. We completed 2016 with 40 POCs, many of them Fortune 500 companies. In all of them, we had great results, much higher detection rate, lower false positives. And so we're frequently asked, well, this thing that you say, this brain is fascinating, but why does it work so good in cybersecurity? I would use an analogy from computer vision. If I, for example, take this glass of water here, if we take a photo of this and show it to a traditional computer vision module, a good one, it will easily recognize it's a glass of water. But if I show it like this, partially obstructing it with my fingers, no traditional computer vision module will be able to detect a glass of water, even the systems using best image processing and best traditional machine learning. But if I take a photo of this with my fingers obstructing it and upload it to Google Photos using deep learning, with very high confidence it will say it's a glass of water. The other day I took a photo of the tail and legs of my dog and uploaded it to Google Photos, and it say it's a King Charles Cavalier Spaniel. Not only got the animal correct, but the breed also correct. So what we see everywhere is that deep learning is very resilient to changes and mutations. It's enough for deep learning to see a small part of the data to be able to generalize and correctly detect what it is seeing. Similar to our brain, by the way. So what happens in the malware world is when you take a new malware, all the good solutions detected. When you just slightly mutate it, analogous to my fingers obstructing it, all traditional methods have great difficulty detecting it. But our deep learning based solutions easily detects it for the same reason that Google's deep learning-based computer vision module easily detects a cat or a dog, even though it's mostly obstructed.
So it's an iterative learning process at the most elemental level of a file, down at the byte level.
That's correct.
Very cool. Well, you guys have also had a very interesting year. So let's shift gears just a little bit, Eli. You guys came out of stealth back in 2015, sort of a coming out party at RSA Conference 2016. And it's been quite a year. You guys have had accolades from Gartner, from Black Hat World, from NVIDIA. Talk to us a little bit about that, and then we'll talk a little bit about what you guys are previewing at RSA 2017.
Sure. First of all, indeed, it has been a very exciting year, very successful year. We have been in several conferences selected as one of the best deep learning companies in general, not in the cybersecurity board, but in deep learning by Forbes, by NVIDIA. And speaking of cybersecurity, specifically, as you mentioned, by Gartner, we nominated Cool Vendor of the Year. We won the award of Most Innovative Cybersecurity of the Company of the Year in Black Hat, numerous other awards. So 2016 has been an extremely good year, and we're looking forward to 2017. Last year in RSA, we showed our new capabilities. It was a coming out parties, and we do have surprises for this year's RSA. We are definitely looking forward to it. We will show some of our capabilities, some of our deep learning based capabilities. And I will encourage everyone to come, and I promise that we will surprise you.
Cool, cool. You guys should have like a big model of a brain there right at your booth. That would be pretty cool.
Of course, all of us has a small brain on our desk.
Excellent, excellent. All right, Eli, thank you very much for taking the time to speak with us today.
Thank you, David. It was great to talk to you.
It was a pleasure. And listen, I will be putting the booth number on the video, so please go and visit Deep Instinct at the RSA conference if you're going to be heading out to that show. So for now, for Deep Instinct, for Dr. Eli David, this is Dave Littman with Truth in IT. Thank you very much for watching, and make it a great day.